Good morning students. Today going to discuss about new lesson kinematics. Okay. Now you see that kinematic concept of motion, rest and motion. You see that you are sitting in the bus. You are sitting inside of the bus. You are sitting in the inside of bus. Okay va? That times the bus is moving. You are in the rest motion. You are in the rest position, but bus is moving. Okay va? Bus is moving. Okay, you see that concept. A person sitting in a moving bus, it's a rest with respect to the fellow, the passenger, but in the motion with respect to a person outside the bus. Okay va? So that the concept of the rest and the motion are the meaning only with a respect to some reference frame. So some reference frame, you see that this is that reference, the three coordinates, x-axis, y-axis and z-axis. So that we are frame. To understand rest or motion, we need a convenient the fixed reference frame. So that is the x-axis. Okay. Now you see the frame of the reference. If we image a coordinate system and the position of the object is described relative to it, then such the coordinate system is called the frame of reference. You see that here you are sitting. Okay. So your coordinates the three axes, x-axis, y-axis and z-axis. Okay, x-axis you are sitting, but you are moving to that y-axis. You are sitting in the rest position. Okay, but bus is moving. Okay, that frame is called the coordinates system. Is called to the frame for reference. At any given instant of the time, the frame of the reference are expected to which the position of the object is described in the terms of the position coordinate. That is, I told you to the x, y, z. Okay, so it's called the Cartesian coordinate system. So this one we are telling to the Cartesian coordinate system. You see that x-axis, y-axis and z-axis. This is the coordinate system. Okay. So next you see that we noted that if the x, y and z-axis are drawn in anti-clockwise, it's moving to the anti-clockwise means x towards move to the y-axis, x towards moving to the y-axis, y towards moving to the z-axis, z moving to the x-axis. This is the anti-clockwise. This is the anti-clockwise. So the called as the coordinate system is called as right-handed Cartesian coordinate. So this is we are telling to the right-handed Cartesian coordinate system. Though other the coordinate system do exist in the physics we are conventionally follow the right hand coordinate system. Okay, so next you see that the distance between the left and the right handed coordinate system. You see that this is this picture. This is the anti-clockwise. So okay, the x towards moving to the y towards moving to the z towards moving to the x-axis. So this side you are left side you are moving. Okay, this is the anti-clockwise, right-handed z up. The right-handed only z up. Okay. So next this one is a left-handed z up. So you see that y-axis going to the y-axis moving to the towards the x-axis, x-axis moving towards the z-axis. So z-axis moving to the y-axis. So it's a left-handed moving. Okay. So this is the clockwise. This is the clockwise. So it's a right to left moving. So this is the clockwise here. So here this x-axis here moving towards the y-axis moving to the towards the z moving to the x-axis. Okay. So this and that. So we see that point mass. To explain the motion of the object, motion of an object which has finite mass, the concept of point mass is a required and very useful. Let the mass of any object be assumed to concentrated at the point. So which point you are taking the rest, that is a very important. That point you are called to the mass, point mass. Idealize the mass is called the point mass. It has no internal structure like the shape and size. So it's not an internal structure like shape and size. Mathematically, a point mass as a finite mass with a zero dimension. So it's not like a shape and size. So the point mass, mathematically the point infinite the mass with a zero dimension, even though the reality point mass does not exist. If after the simplify our calculation, it is to be the noted that the term point mass, it's a relative terms. It has the meaning only respected to the reference frame. It is meaning to the only reference frame, and with the respect to the kind of the motion that we analyzes. Example, you see that one example. To analyze the motion of the earth with the respect to the sun. Okay, wow. The motion of the motion of earth with the respect to the sun. The earth can be treated as the point mass. This because the distance between the sun and the earth is very large compared to the size of the earth. Sun size and earth size we are compared to that. It's very large in the sun. Okay, wow. The earth is a smaller size only, but the distance is very large. Next one, the types of motion. So type of motion, first one is a linear motion. An object is said to be the linear motion if it is moving in a straight line. It is moving in the straight line. So an athletic running on a straight track. The athletic running on the straight track. The car moving to the straight line. Okay, straight road. Okay, this and all we are telling to that examples. So next is circular motion. The circular motion is defined as the motion described by an object traversing a circular path. The circular path, one point, the circular path only they are moving. The example to that you see that planet. The planets is moving to the circular orbital, right? The orbital moving only. Okay, that is a circular path. So next to the whirling motion of the stones attached to the string. Once we are taking to the one thread and tied to the stones and you are rotating. So that is also you are going to that circular motion only. Okay. And next the motion of a satellite around the earth. The motion of a satellite around to the earth. This is the circular motion. Okay. So next you see the rotational motion. If any object moves in the rotational motion about on the axis. So rotational motion means it's about the axis. So spinning of the tap. Spinning of the tap. Spinning of the tap. It is the axis of the rotation. Is axis of the rotation. If you see, if the object moves in the rotation motion about on the axis, the motion is called the rotation. During the rotation, every point in the object transverses a circular path about and the axis. It is going also the circular path, but it's about and the point, the center point. It's a axis. Okay, wow. So next example. The rotation of the disc about and the axis through the in its center, the spinning of the earth, the spinning of the top, this and all we are telling to. So vibratory motions. So vibratory motions here, to and fro motions. If on the object or particle executes a to and fro motion. Today the Aarti asking the what is that means to and fro motion. You know, the today live class. So you see that that is what it means. Front and back moving, front forward moving and backward moving, that is we are called it a to and fro motion about a fixed point. It is said to be the vibratory motions. So this and all we are telling to the vibratory motion. This is sometimes called oscillatory motion. Oscillatory motion. Example we are taking to the simple pendulum. The simple pendulum, one side it's a tie out the one, we are taking to the thread, one side you are one end of you are tied to the bob, one end you are tied to that hanging, then you are and here the your string is here, you are moving to that means what happened, it's a here and there moving. Okay, so next swing, the movement of the swing also. Okay, you are going to the park, you swing, no, that one. So example of the vibration of the string and the guitar, movement of the swing. Okay. So next you see that you see that motion is here one. So now the different types of motions are. So next the dimension. The motion is a dimensional. It having to the one dimensional, two dimensional and three dimensions. Okay. So let the position of the particle. Let the position of the particle in the space be exposed in the terms of the rectangular coordinates. Coordinates already I taught that the coordinates is a x, y, z the coordinate. This coordinates. So that one they are telling the time in the this coordinate change to within the time. The coordinates change within the time. Then the particle said to be in the motion. However, it is not necessary that all the three coordinates should be together change. It not necessary. It's all the coordinates together change. It's a one by one change or twice a change that and all. Okay. So even if one or two coordinate changes with the time, the particle is said to be in the motion. So one or two coordinate change with the time within the time it's a changing means we are called to that motion. Then we have the following the classification. So now we are follow to the classification. First one is a motion in one dimension. So one dimensional motion is the motion of the particles moving along a straight line. One dimension means it's a moving along the straight line. It is that object moving to the one directions. You think it the object moving to that one direction. That is a rectilinear or linear motion. So you are given the example. Only one of the three rectangular coordinates specific the position of the object changes with the time. For example, the car moving from the position A to B along x direction. Okay, so this is a x coordinate along the notified. Okay, vibrate. So example of the motion of the train along a straight railway track on object falling freely under the gravity close to the earth. Okay. So next one, motion in the two dimensional. If a particle is moving along a curved path in the plane, then it is said to be the two dimensional motion. You see that example of the aeroplane, you take that aeroplane. So first it's a moving to the straight line. The plane, aeroplane moving to the one straight line, right? The track, the pad, either pad, that word I forgot it, that one pad, helipad, that pad, it's a straightly that aeroplane, so moving to that the straight line, it's a moving after the direction is changed. After it's a direction is here, what happens? It's a curvely, it's here moving up, right? So moving to the up. So the direction is here change. So that are two dimensional. So x axis and z axis. Okay. So that two direction. So x axis. Okay. Then example of the motion of the coin on a carom board on insect traveling over the floor of a room also. So next, third motion, insect curving. Insect means curving means the insect floor lo run over. So motion in the three dimensions. Next part is a three dimension. The particle moving in the usually three dimensional space as the three dimensional motion. In this motion, all the three coordinates specific the position of an object change with the respect to the time. The moving, it's a change with the respect of the time. When the particle moves in the three dimension, all the three coordinates. Three dimension means it's a three coordinates x, y and z. Okay, very. So example of a bird flying in the sky. Random motion of the gas molecule flying of the kite on the windy day. Okay. So the gas is the molecule spread in the air. So any directions are moving. The three directions are moving to that. So it is a random motion of the gas molecules. It's an example of the example of that motion in the three dimensional. Okay. So next one. Next one you see that elementary concept. Next one is a elementary concept of the vector algebra. Elementary concept of the vector algebra. Okay. So next you see that in the physics some quantities passes only magnitude. Okay. some quantities, the physical quantity, some quantity passes only magnitude and some quantity passes the both magnitude and direction. To understand this physical quantity is very important to the properties of the vector and scalar. Okay, well, you are define the scalar means it's a magnitude only. Okay, the physical quantity. It is the physical quantity. It is a property which can be described only by the magnitude. Only by the magnitude. In physics, a number of quantities can be described by the scalar. Sum of quantity we can be described means only by magnitude. Only by magnitude which we verify panna poradha physical quantity we are telling to the scalar. This is the scalar. So example of distance, mass, temperature, speed and energy. Next one vector. It is a quantity which is described by both magnitude and direction. Geometrically a vector. So vector quantity is described by the both magnitude and direction. Geometrically a vector is a directed the line segment. So vector means what? It's a direct to the line segments. Okay, which directions are. Then the next the example of the force, velocity, displacement, position vectors, acceleration, linear momentum and angular momentum also. So you see that next magnitude of the vector. The length of a vector is called magnitude of the vector. So length of the vector, understood that? Length of the vector is called the magnitude of the vector. It is always the positive quantity. It's always the positive quantity. Sometimes the magnitude of the vector is also called the norm of the vector. The new name norm of the vector. Okay, norm of the vector. So how do we are called a vector? The magnitude. The norm is your vector. How to your vector you are called means a vector. So next the magnitude or norm is denoted by modulus of a vector or apply a. Okay, this is the vector quantities. So next one, different types of the vector. So different types of the vector. You see that equal vector, collinear vector, parallel vector, anti-parallel vector, unit vector, orthogonal vector. So first we are going to discuss about equal vector. Equal vector now you see that one pair or line, that x-axis you are moving to the one line. This line it's parallelly going to the another one line. Okay, so this is the equal. The two vector a vector and b vector are said to be the equal. The a vector and b vector equal. It's a parallel line. It's a parallelly it's going to that x-axis. When they have the equal magnitude and the same direction. So the magnitude also equal and the direction also equal. The same direction, same physical quantity. Okay. So collinear vectors. The collinear vectors are those which act along the same line. The angle between the 0 degree or 180 degree. The collinear vector two types having. One is 0 degree angle between the angle. The angle depend the split to the two. Okay, two vector collinear vectors. One is a parallel vector, another one is a anti-parallel vector. So 0 degree one, another one is a 180 degree. So you see that parallel vector, you see that diagram. This is the x-axis. The x-axis we are going to the one line. The parallel line, another one line going to that. So a vector, this is a b vector. This is what it's a same act on the same magnitude and same direction. So it's moving to the same direction. So this is the 0 degree. This is the 0 degree moving. Its angle is a 0 degree. It's a moving. So it is a parallel vector. So next one, anti-parallel vector. What is that anti-parallel vector? You see that parallelly going to two lines, two axis lines moving to the parallelly, but the direction is a differ. The direction is a different. One is going to the right side, another one is going to the left side. So this angle is, you are merged to the two lines, its angle is a 180 degree. So A vector and B vector is joined to that, creating the 180 degree. So this is the anti-parallel vector. Okay, wow. So next, unit vector. The vector divided by its magnitude, it's a unit vector. The vector divided by its magnitude. Or vector divided by the magnitude, it is called the unit vector. The unit vector for A vector is denoted by the A cap. We are denoted by the A cap. Okay, it has the magnitude equal to the unit or 1. So since A cap equal to A vector divided by A, cross multiply you are doing means A vector equal to A cap. Okay, so it's a direction. So you can say that the unit vector must be only the direction of the vector quantity. Okay. So next, the orthogonal unit vector. So orthogonal unity vector is here I, J and K. This is the 3 unit vector. This is the 3 unit vector. Okay. The specific the direction along that positive x axis, positive y axis, positive z axis. Okay. Wow. So it's a perpendicular. Each one is a perpendicular. So you see that zx is a perpendicular. So next one you see that this is the perpendicular. You see that this is the perpendicular. So each one is a perpendicular in moving. So we are taking to the I cap, J cap, Z cap. Okay. So sorry, I, J, K caps. Okay. Okay. Its angle is between the 90 degree. Are you understood, students? Thank you.